So in this question here, this is all focusing on circles, formula circles, and relationships between two circles that we put in 2 dimensions. So I've got 2 equations of circles here, C1 and C2. First part is calculate distance between the centres of the 2 circles. And then I want to show that the 2 circles intersect at 2 distinct points. So there's a special property we have to make sure that we can prove when it comes to part B. Part A, we obviously need the 2 centres, then we need to use our distance formula. So if we look at part A first, and I think about the centre of circle C1. Now there's 2 forms of the circle equation that we've got here. We've got x minus a squared plus y minus b squared equals r squared. So that's one format of it, and that's the way C1 is written. From that format, the a and the b represent the centre. So if I look at that, for C1, I can say that my centre is given by 4, negative 2. Now if I look at C2, circle 2, that's written in the format x squared plus y squared plus 2fx plus 2gy plus c equals 0. Now for this one here, my centre is negative f, negative g. So what I have to do is equate those and figure it out. Now if I look at just the coefficients here, so the coefficient of f in this one, the 2f, that's going to be the equivalent of 2 in the equation that's given me over here. So if 2f is 2, then f is equal to 1. But for the centre of the circle, it's negative f. So if f is 1, the negative f gives me negative 1. I've then got 2g for my y coefficient, negative 6 for the other one. So I know 2g is equal to negative 6, so g is equal to negative 3. But again, it's negative g for the centre. So if g is negative 3, then the negative g is 3. So the centre of my second circle is given by negative 1, 3. If I then say my distance between the 2 centres, I can use the distance formula, which is x1 minus x2 squared plus the y1 minus y2 squared. And that x1, x2, y1, y2, they come from the centres of the 2 circles. So if I substitute those values in, what I'll end up getting is the square root of 4 minus negative 1 squared plus negative 2 minus 3 squared. So that's going to be equal to the equivalent of the square root. 4 minus minus 1 is 5, so 5 squared is 25. Negative 2 minus 3 is negative 5. Negative 5 squared is 25, which then gives me root 50. Now root 50 can be simplified down to 5 root 2. Or if we went for a decimal value, which may come in handy later on, it's actually equal to 7.07, and then it continues on. That decimal value will come in handy a little bit later. Sometimes it's worth calculating at this stage, sometimes it's not. You wouldn't be penalised if you didn't at this point. As I say, it's just handy for later on. Now for part B, it says hence show that C1 and C2 intersect at 2 distinct points. So what that means is I've got my 2 circles and they intersect in that manner here. Now, there's a property for this that we have to be able to prove. If I look at the circle on the left, and I go from the centre to the edge, that's going to be R1. If I then look at the circle on the right, and I go from centre to the edge, that's going to be R2. Now you'll notice that I've also got the distance between the centre of the 2 circles, marked in the green line, as being D. Now, if I look at that, what I can say is that in this case, the distance between the 2 centres is less than the 2 radii added together. If that property there is kept up, what that then means is the 2 circles intersect at 2 distinct points. So I now have to prove it. Now, I have my distance, root 50, 7.07. I need to figure out the 2 radii for the 2 circles and add them together and see what I get from that. So if I think radius 1, R1, Let's go for that from being C1. Well, if I refer back to my original formula, r squared is on the right-hand side. So for circle 1, r squared is 37. So if I call it r1, I know that that is going to be the square root of 37. Now, if I were to use a calculator and get that, I get 6.08, and again it would continue on. If I then wanted to look at r2, so that's from circle 2. Now, with the way it's written, there's actually a very, very quick, easy way that I can do this and calculate the radius of the circle. I can use the fact that the radius, so we'll call this r2, is equal to the square root of g squared plus f squared minus c, from the formula and the way it's written. Now, I said earlier on, I know what f is, so I know that f is equal to 1. I know what g is, I know that g is equal to -3, and then c is just the constant at the end, which in this case is -7. So it's going to be the square root of the g squared, so 3 squared, plus the f squared, so plus 1 squared. Take away the c, and I know the c is -7. So what I'm going to do is calculate that. So 3 squared is 9, 1 squared is 1, so that's 10. Then it's minus minus 7, minus minus becomes a plus. So it's 10 plus 7, so that's equal to the square root of 17. Now if I calculate the square root of 17, I get 4.12, and then again it continues on. So what I can do is, if I look at this, and I do r1 plus r2, what I end up getting is I get 10.2, and then it continues on from there. Now, even just looking at the numbers again, this is why taking the square root from part A is something that could be quite good, because I can compare it directly and say that 10.2, well, that's definitely greater than 7.07. So from that, what I can say is R1 plus R2 is greater than D, my distance formula. So that implies the circles intersect at 2 distinct points. Intersect at 2 distinct points. So I'm able to make that conclusion because that property exists. So there you go, working it through and thinking about those sort of parts there, that's what we're able to do. Now, for working with circles, we have to remember these two key formula here. And again, it's quite nice because both of those are actually given in the formula list. So we've got them at hand. Again, if we have a brain fart and forget, they're available to us so we can use them to compare for our question. And I would suggest using them just to back up what your understanding is. If you're thinking to yourself, oof, I'm not quite 100% sure of that, just double check. Make sure you don't lose any silly marks. And make sure you're thinking about how the circles relate to one another in terms of their position for a question like part B. What do we know about them intersecting at 2 points? Touching at a point, not touching at all, anything like that. We have to be able to prove any of those, and we have to be able to work with all of these in order to be able to get it. Now, a question like this, part A and part B, worth 3 marks each. For part A, you get a mark for each of the 2 centres, and then you get a mark for using the distance formula. For part B, you get a mark for each of the 2 radii, and then you get a mark for this whole spiel here at the end. So saying what it means, so the R1 plus R2 is bigger than D, and then interpreting it. Again, it's the conclusion. So if you say R1 plus R2 is bigger than D, so what? What does that mean in this scenario? Or if you just do the maths on the left and just get your 2 radii, and then right therefore the circles intersect at 2 distinct points, someone will be able to turn back to you and say, why? So you've then got to delve deeper into it and explain it to them. So bear that in mind. So bear in mind the interpretive side of it, bear in mind the formula, and bear in mind the positions in relation to one another and the key properties of them. If you bear all of that in mind, and you work hard at this question, there's no reason that you can't get the marks on this, and there's no reason that you can't find these easier than they initially look or you initially think. Don't panic yourself. Don't worry yourself. Think of the techniques, look at the formula, and take your time. If you do all of that, when it comes to working it through, you'll find a question like this. Easy peasy, lemon squeezy.